So welcome all of you to the workshop. The topic that I'm going to discuss today is the reporting bias and the publication bias. And the one of the image you can see on the slide. So this is very important chart in publication bias. So we will discuss that how the this chart indicate the biasness in the publication, especially in meta-analysis. Okay. Now there are different problems in the biasness in the reporting bias. And the basic problem in reporting bias is that the papers are divided into two categories. The paper where results are significant and the papers where results are not significant. So the first biasness which comes uh, is known as the reporting bias. So this is, if you read these statements, this statement I took from a book written. The name of the book is The Reporting Bias Through Intervention by Cochrane, and I will also share this book to you. So now read the line. Statistically significant positive results that indicate an intervention work are more likely to be published, more likely to be published rapidly, more likely to be published in English, more likely to be published more than once, more likely to be published in high impact journals, and related to last point, more likely to be cited by others. So which are these studies? So these are the studies where the results are significant. Right. The contribution made to the totality of evidence in systematic reviews by studies with non-significant result is as important as those studies with statistically significant results. So what the author want to say? Author want to say that there are two kind of studies where results are significant and the results are not significant. And it is a human tendency to include those studies where results are significant. Similarly, the journal would like to publish those studies where results are significant. Obviously, citation is high. So this is a kind of biasness, right? And because of this kind of biasness, there are many problems comes in the analysis. So this is the one kind of biasness. And the biasness is also divided into different categories. These are the different type of biasness. So publication bias, you can see, is a subset of the biasness. And the publication biasness, so these are the different kind of biasness. Publication bias, time lag bias, multiple publication bias, location bias, citation bias, language bias, outcome reporting bias. So let's discuss one by one. Now, publication bias is that actually uh, we identify different kind of studies, we have a biased attitude towards the studies where results are significant and where results are not significant. So the publication or non-publication of research findings depending on the nature and the direction of the results. As I said that the studies where results are significant are more likely to be published, and the studies which are not where results are not significant, the studies are not likely to be published. So I'm giving you one example. Today morning I was sitting with my client, and she is a student of London School of Economics, some college in London, it's reputed. Now the project is that I have to apply the mediation and moderation results between the leadership and their some dependent variable. And unfortunately, the results say that there is no moderating effect. Then the scholar feel depressing. So she said that I collected these studies from different corporate leaders. I took this 6 months of collecting the data, and theory say that there is a significant moderation effect, but in my study there is no moderating effect. So what to do? So actually, it is very common. So when you don't have significant results, so the question is that what to do with these studies. So what to do with these studies, right? So in most of the cases, the researchers feel very depressed and they may quit from the research. So they may not publish these kind of research. And even if you send your paper for publication, it may be rejected on the basis of your results. So finally, what studies we have in the meta-analysis are those studies which are published on the basis of their results, which may be biased. This is a problem called publication bias. Time lag bias. There, you know that in good journals, if you send your paper for publication, you will get acceptance in 1 year, and the paper will publish in 3 years. So there is a time delay in the publication, and it may be possible that you may not include these papers, right? So because if you are having problem in the results, or if you are having some problems on the basis of which your publication is delayed too long, and these studies are not published included in your study, so that is also cause a bias called time lag bias. Then the third kind of biasness is called multiple publication bias. Actually, most of the scholars, most of the researchers, they published in hardly one or two areas, because I know many researchers who pick a topic and they like to publish around that topic. So topic is same, but they publish and they go in depth and publish many papers on that study. So what happens when you collected the papers, you found that same author wrote 10 papers on the same topic. So you may have a biasness to take few papers of those that author. You may exclude some of them. So this is also a concept of multiple publication bias, right? Then you selected only those papers where results are good, and you exclude those papers where results are not good. Then location bias. Location bias means you may include these studies in US, India, Europe, developed countries. You may not include those studies which are conducted in Afghanistan, Bangladesh, Sri Lanka, maybe, or Africa, Ghana. So there may be a location bias. And again, if you see the definition, it may be possible that you may not include those studies which are published in paid journals, because I know that many Indians in hurry, they publish their papers in paid journals, and the papers are really very good, right? So it is also a problem that you ignore good papers because they are published in low quality journals. The citation bias, this is a very common bias we are having. But although I always recommend those papers which are having high citation, it may be a biasness. We have a tendency to include only those papers which are having good citation. So this may be the biasness. Language bias. Language bias means we are not taking the papers which are written in Chinese language, Russian language, German language, right? Because we are not able to read them, so we ignore them. So this is called language bias. Then even in a paper, there are many outcomes. So some outcomes we reported and some outcomes we never reported. So we have a tendency to report only those results which are useful for us, and we are not reporting those results which are not useful for us. So this is called outcome reporting biasness. So that the problem is that the study may be biased study. The meta-analysis you are doing may be the biased study because of these known and unknown biases. Now the problem is that, so the rest of my session will discuss only two things: how to measure these biasness, right, and how to interpret these biasness. Okay, now there is a problem. Rothenzel, who contributed a lot in this area, he gave a new concept. The concept is called file drawer problem. The file drawer problem, right? And I hope you understand what is the file drawer problem. The file drawer problem is that if you are writing a study and your results are not found to be significant, so what you do? You put that study in the drawer or a almirah or in Riddhi, right? So that problem is known as file drawer problem. So like you can see in the picture that the lady is saying that, and this is where we put the non-significant result. So this is a drawer, and there are many non-significant results in this drawer. So the concept is very simple. If we do a study and found significant results, we feel enthusiastic and publish and send the results for publication. And in case if we are doing a study but the results are not found to be significant, so what we do, we put the study into the drawer. So we don't like to publish those studies. Even I tell you, because in finance, some unique idea always comes in my mind, and I want to prove that ideas. And when I found that these ideas are not significant, then I drop it. So I have many half-written papers. I also have this, that because the half-written papers means I found the results insignificant, so I stop writing, and it is a common problem. So because of this problem, we are not including those studies in our meta-analysis which are having non-significant results, right? So the Rothenzel wrote an article. So although the article is very, very old, in a 1979 article, the file drawer problem and tolerance for null results, Rothansel described a gloomy scenario where the journals are filled with 5% of the studies that show type 1 error, where the file drawer back to the lab are filled with 95 of the studies that show non-significant results. Right. So this is the most important statement by Rothansel, that 95% of the studies which are non-significant are there in the drawers, and 5% of the studies which are having significant results, they are published by the journals. So this problem is known as file drawer problem, which leads to the biasness in most of the meta-analysis results. Okay. Now the problem is that how to measure these results. Now you read the question. The basic question which comes in the mind of every researcher: how can I say my study is biased, or do my meta-analysis suffering from publication bias? I want to know. So I want to know whether the meta-analysis done by me is suffering from publication bias. So answer. So to find out the answer, the first answer is coming from the funnel plot. So this plot is known as funnel plot. Right. Okay. Now actually, the funnel plot is the problem with funnel plot is that it is very difficult to understand. I'm telling you. And there are two tests on the are based on this funnel plot. The test number 1 is simply the funnel plot by looking at the funnel plot, and second test, which is based on the funnel plot, is called trim and fill test. So we can understand only these two tests if we understand the funnel first. So now I'm going to explain what is this funnel in my own language, right? Okay, so let me show one experiment to you. After that, I will ask something to you and will explain you the funnel. So let me open the Meta Essential, and I'm going to conduct one experiment. Just see what experiment I'm going to do. So this is my Meta Essential file, and I'm opening the file of correlation data. Okay, so in this case, in this data set, the input data is my correlation, right? So this is the data. So I did one experiment, simple experiment. I arrange all this data set. Let me actually, the original data set was like this. So let me sort from smallest to the, okay. Now this is the data set I have originally. So I found that some of the samples have large sample size, and some of these studies have the low sample size, right? So now what I want to do, I want to arrange all these studies in descending order as per the sample size. The original funnel plot is like, original forest plot is like this. Just see this original plot. And after the experiment, then you will see what changes comes in the funnel plot, and I will ask you the question. So just see this funnel plot. See carefully. See this funnel plot, forest plot. I hope you have seen it. Okay, now if I arrange the sample size in descending order, okay, now you can see that the study which is having the highest sample size comes on the first, and the study with the lowest sample size comes in the last. I hope you can see that. So this is just one experiment. Now, if I plot the funnel plot, if I say the plot, forest plot, the forest plot seems like this, right? This is a kind of triangle you can see. It is a kind of triangle, right? So I will show you that this is a kind of triangle it is showing. Now I want to invert this triangle. So invert this triangle means I want to make opposite of it. So let me do one thing again. I will arrange this data again in smallest to the largest. So I'm sorting it. Now I have the smallest number on the top and the largest sample size on the bottom. After that, let's see the forest plot. Now I am having the inverse triangle, right? So now I can see this is the inverse triangle. So we are having two type of triangles, inverted and non-inverted. Because my interest is in previous, so let me do Control Z, so that I will back to the second case. Okay, let the software run. Okay, now software run it, and we are having the plot. Okay, now we are going to discuss this plot. This plot is like this. Let me plot like this. So we are having this plot. right? So we are having this plot. Now my question is very simple. Why this plot looks like a funnel, right? Ideally, this is a funnel plot. And my simple question is that on what basis the picture of this funnel looks like this? So use your common sense and tell me the answer. Because if you don't understand this, you cannot understand the case of publication biasness. So I'm asking to you, I showed you the result. I arranged the studies in the ascending order so that the first study is having the lowest sample size. Okay. Now the last study is having the largest sample size. Right? Okay. I hope you are getting me. And I'm asking some things to you and give me the answer. So let me discuss in the white page. Okay. Suppose this is my diamond. Let's say this is my diamond, right? We are having two type of studies. We are having two type of studies. One with big size, big studies. I hope you understand the big means the sample size is large. And second is small studies where sample size is small. So we are having the two type of studies, big studies and small studies. And these big studies is having the low variance. I hope you agree with me. And a small study is having the high variance. The small studies is having the high variance. Okay. I hope there is no doubt in it. So because these concepts we are discussing from the last 4 days. So there are two types of studies, big studies and the small studies. Okay, very good. I hope there is no confusion. So let me check it. Yeah. So you are saying that there is no confusion. If there is confusion, please tell me so that I can explain it. So we have seen that there are two types of studies. We have seen in the forest plot. There are two types of studies, big studies, small studies. Big studies means studies which are conducted on the large sample size, small studies which are conducted on the small sample size. And big studies have the low variance and small studies have the high variance. Okay, now you know this. Now I'm taking the y-axis, I am making this y-axis and I'm saying it is a sample size. This is a sample size. And this is my the correlation. And my diamond is here. My diamond is here. Right. So if I plot the different studies, this study which is having the highest sample size, this study which is having the highest sample size should have the low variance. Study number B is having the high variance, slightly higher variance than previous one. Because this study is having the low sample size than A. This is study A, this is study B, and this study is having slightly higher variance. Why? Because the sample size is low. Then we are having study C, which is having the less sample size than A and B. So as you move downward, the variance increases. Right. So finally, we are having the studies like this. So I hope you understand the concept. So the studies with the high sample size will have the low variance, and a study with the having the low sample size are having the high variance. So if you plot these variance, if you plot this variance, so you are getting what? This is called funnel plot. Funnel plot. But actually, the funnel plot is changed slowly. Now this sample size is replaced by the under root of the variance, because initially who made this plot, he just take the sample size. But the problem is that sample size, we are not taking the sample size for calculating the weight. What we are taking the degree of freedom, and after that we calculate the variance. So somebody take the variance in the y-axis, but again same problem. Variance is the square value. So we should not take the variance, rather we should take the, let me change it, variance by, I am replacing the variance by standard error. Standard error is nothing, it is the square root of the variance. It is square root of the variance. Now the concept is same. If sample size is very high, variance is low. So the study A study must have the lowest standard error, and this is a F study or G study, H study. The study is having the lowest sample size but have the highest variance or highest standard error. So that's why this funnel is an inverted funnel. like a pyramid, and in this pyramid the base is very breadth of the base is high, right, and the breadth of the top is small. So this is like a pyramid, and the logic of this pyramid is that in the lower side we are having those studies which are having high variance because of the low standard error or low sample size, and in the top we are having only those studies which are having high sample size, large sample size, and that's why low variance. So because of the low variance, it is like a triangle, it is like a pyramid, it is like a inverted funnel. So this is the logic of this funnel plot. Now what happens if some study is lying outside, right? So we consider then this is the outlier. If some study is lying outside the funnel, we assume that this is the outlier. Now these outlier, right, these outliers are the outliers maybe because of the very low sample size, because if the sample size is very high, all these studies comes near to the diamond. Only those studies which are having very low sample size and having a large variance will scatter there and here and there. So we want to find out if most of the studies are coming outside this funnel. So this is a measurement of biasness. So it means your study may be biased because your studies are having a lot of heterogeneity, and because of this you may have publication biasness. So this is the logic of funnel plot. I hope the way I explain you should understand this. Otherwise, this language is not found in any book, but because we are statisticians, so we understand the logic of the funnel plot. Okay, fine. I'm going back to the slide, assuming that you understand the funnel plot now. So we are having the forest plot like this. It is actually like a funnel. It is actually like a funnel because in this diamond, most of the studies which with heavy sample size are near to this, and the other studies which are having low sample size are far from it. And the standard error of the top studies are low, and the studies which are having low sample size, their variances are very high. Okay, now let's go back to the funnel. So after understanding the concept of the funnel, now what we are going to understand. A funnel plot is nothing, it is a scatter plot of the effect size from the individual studies. Here y-axis, you can see the y-axis is the standard error. Directly or indirectly, it is sample size. Because if you understand with respect to sample size, the understanding will be very high. So the y-axis is indicating the standard error, and x-axis indicate the effect size of the study. The plot should ideally resemble a pyramid that we understand, with scatter due to sampling variation. The variation is high in the bottom and the variation is low in the top. This shape is expected because these studies have a very wide range of standard errors. Okay, now and all so all the points are expected to come inside the funnel, and missing studies represented by the publication bias in a meta study lead to noticeable asymmetric funnel plot. Now you understand what is the reason of asymmetric. If this funnel plot is asymmetric or studies are coming outside it, it is indicating the publication bias. So I hope you understand now the concept of funnel plot. And the problem of asymmetric funnel is showing you the large level of heterogeneity or the large publication bias in your study. So let's move. Now the question is that, is looking at the funnel plot is the only solution? Do we have only this method of identifying the publication bias? No, we are having many tests also. Which are these tests? Let's see. Okay, so the Cochrane book explain these are the different reasons of the asymmetry of the funnel. These are, if you see the heading, these are the different possible sources of asymmetry in the funnel plot. So you may be selection bias, poor methodology, heterogeneity, right, artifactual. So we are, because the study may be different, maybe have biasness, maybe having large heterogeneity, and because of this, the second point is quite interesting. Poor methodological studies quality leading to spuriously inflated results in small studies. Actually, if I found that not only in India, in almost every country, there is a habit of outlier removal, data manipulation, and so because of these problems, you may have the spurious results. So this is one of the problems that whenever we collect the data from the primary survey, we used to correct the data or manipulate the data to some extent so that we will get the significant results. And if anybody of you write a paper on the questionnaire based studies, so you know that some manipulations are required. Okay, because of that we are having some faulty results, but because we are showing the significant results, so the publication becomes easier. And I have seen the champions of the manipulations in top B schools of India, not only in India, top B schools of the foreign universities. So I call them lab researchers because they made the data in lab, like in their cabins, write the paper in their cabins, publish their papers without going outside. So the problem is there, right? The problem is actually there. So because of all these hidden reasons, we are having the biasness in your meta-analysis results, right? And we can't do anything in that. Sometimes it is happen that heterogeneity is there. Yeah, in medical science, we are not doing the manipulations, but because of the heterogeneity, we have the heterogeneity. In finance, because I know that in finance we can't manipulate the data. In economics, you can't manipulate the data. In medical science, you can't manipulate the data. So most of the manipulation are based on primary surveys. So sometimes there is a true heterogeneity, and because of that, we are having the asymmetrical funnel plot. But it is there. So these are the different reasons. So selection biases I already explained to you: language citation bias, multiplication population bias, and these are some of the other reasons which, because of which you are having the heterogeneity or the asymmetry funnel plot. Okay, so let's move. Now, one of the tests which is available to examine the funnel, the publication bias is called Bag and Mazumdar rank correlation test. And Mazumdar, you know that Mazumdar is normally Bengali. I feel happy when I see the name of Indian in any test. Okay, so this Bag and Mazumdar give a test. So what they do, they say that if there is a relationship between the effect size and the sample size, right? Listen carefully. They say that if there is a correlation between the effect size and the sample size, it may indicate some sort of biasness, right? And because the number of studies, in a meta-analysis is very low, hardly 20, 30, 40. So they calculate the Kendall-Tau correlation. Now, the property of Kendall-Tau correlation is that Kendall-Tau correlation calculate the rank of the variable X and the variable Y. And then they calculate the correlation between the rank of the variables. So this is called rank correlation. So according to the Bag and Mazumdar test, this correlation test is called rank correlation test because of the low sample size. It is a non-parametric correlation. So they say that if the probability value of rank correlation test is found to be insignificant, it means no direct biasness is there. But in case if they are significantly related, if there is a significant rank correlation between the effect size and the sample size, no, sample size is represented by the variance and standard error I told you earlier. So they calculate the correlation between the variance and the index effect size. And if this correlation is found to be significant, it means publication bias is there. Simple. Now the problem is that, number one, the power of this test is very poor. And this correlation also depends upon the parameter. Parameter means whether the effect size is odd ratio, whether the effect size is risk ratio, whether the effect size is correlation. So this test depends upon the parameter. So this is the problem of this Bag and Mazumdar rank test. But most of the softwares are showing you the result of Bag and Mazumdar. So if you want, you can report it. Okay. So this is one of the tests which checks whether the studies are having publication bias or no. Okay. So they say that unless you have many studies in your meta-analysis, the Bag method has very low power to detect bias. Means if your number of sample size is very low, then the power of this test is very low. So you must have 30, 40 studies for applying this test. Okay, so let's move next. Now the next test is called eager regression test. Now eager regression say that if the p-value of the intercept, listen carefully, because in this test, in almost every regression, we find out the p-value of the independent variable. But here we are not finding out the value of independent variable. We are looking at the p-value of intercept. This is different. This is quite different, right? So we don't know what is dependent and independent. I have not found that. Obviously, the effect size is dependent, and they say that in case if the p-value of intercept is found to be significant, as you can see in this picture also. This picture is coming from the meta regression. I will show you that. Then we can say biasness is there. if this p-value of intercept, this is the p-value of intercept. If the p-value of intercept is found to be insignificant, then we can say the biasness is not there. Right. So this is the theory. This is the line which I took from one of the paper. You can read it. And okay, but I hope you understand the meaning. So because this test is also available in Meta Essential, and in Meta Essential we will check what is the probability value of the intercept of the Agar regression. Significant means biased. Insignificant means unbiased. Okay. Now I'm showing you, because we are having the data of case 3, and when I apply the case 3 result, so I'm getting this result. Now tell me, can we say the studies are biased, or can we say studies are not biased? Now use your mind to answer. Can I say my studies are biased or my studies are not biased? The results I'm showing you is the results of case number 3, which I already shared with you, and I will show you the demonstration of Meta Essential also. Now, but I want to know whether my study is biased or not. Whether the data which I shared you indicate the publication bias or not. Kya baat hai? All the answers are right. So you say that in the given study the publication bias is not there, and answer is very simple. You have to check this p-value, right? So because this p-value is more than 0.05, so not biased. Then I have this z value and p value. This p value is also find out is more than 0.05. So my result is that not biased. So I hope all of you are with me and understanding the concepts. So I'm showing you the result of back-end Mazumdar test and Eager regression test. So yeah. So all of you say that you are with me. Good. Now in Meta Essential, we are having 3 more tests. So 3 tests we already done: funnel plot, back-end Mazumdar, Eager regression. Now the software will also show you the standardized residual histogram. And the rule is very simple. If most of the bars are lying under the normal curve, then we can say the studies is not biased. And in case the studies are most of the studies are absolutely outside this normal distribution, it means the study is biased. So what we are doing here, so we are taking the standardized residuals of the regression, and we plot them and check whether they are normally distributed or not. This orange line is showing you the normal distribution, and if most of the studies are under this, then we can say there is no p-value, there is no nothing like here in this. You just find out whether most of the studies are becoming a normal distribution, forming a normal distribution or not. Similarly, this is the Galbraith plot. Galbraith plot is more easy. It is just a plot. So the Galbraith plot say that if most of the studies are between these two extreme lines, it means your meta study is not biased. However, in this case, we can see that there are few outliers, like this is the outlier, this is the outlier. So you can identify that which studies are creating the publication bias and which studies are having results different from your diamond, right? So you can identify that whether most of my studies are lying between the range, or there are some studies which are lying outside the range. So you can see this picture and find out that how many studies are lying outside the range and how many studies are lying inside the range. So this is simply a plot known as Galbraith plot. So we are having one more plot that is known as the normal quantile plot. So in this normal quantile plot, again it is a symbolic, it is a plot. There is no statistical test here, and we want to see whether most of the studies are most of the dots are near to the straight line or far from the straight line. If most of these studies are near to the straight line, it indicates the no publication bias. And if the dots are very far from the straight line, then we can say that there is a probability of biasness. So these are some of the graphical ways to represent the publication biasness. But the problem in last 4 tests that we cannot analyze by any statistical method whether the studies are biased or not. Like if we check normal plot, Gabriel plot, and standardized residual diagram, they're just indicators, graphical indicators. They are not giving you any value of the test. So we want some better test, right? Some more tests we require. So we are having some more tests. Let me show you that. Okay. So there is a concept called fail-safe test. Now I'm telling you the logic of fail-safe test. So this test start with a question. This test start with a question that if you increases the sample size or in meta-analysis, right? We know that we are having a central limit theorem or the law of large number, which say that if you increase your sample size, the result will comes accurate. The accuracy of the result will increase. So there is a simple rule in the statistics that if you increase your sample size, you will reach to the true population value and the accuracy of the result will increase. So Rothansal ask you a simple question that what should be the ideal sample size so that I will not having any biasness, right? So how many studies I should have, how many studies I should have so that the biasness will go. Now the problem is that how can we identify? What is the logic that we can identify? What is the logic that we can identify that if we include these studies, that these studies will be unbiased, that the result will be unbiased. So Rothansal do one thing, right? वो कान को ऐसे पकड़ के उसने ऐसे पकड़ लिया. So he said, rather than finding out how many studies if you include, you should include to find out the accurate results. Now I will give you a method that how many studies we can add so that your result will be zero. Your result will be insignificant. Now listen carefully. Listen carefully. How many studies I should include to make my results of meta-analysis insignificant, right? So this is the logic of Rothansal. Like I'm telling you one thing, the null hypothesis of this test is that how many studies I will include. So I will find the number of studies to be included in the study so that my effect size, mean effect size will be zero. So like in this case, this is the result of my data set, which I shared with you. The 316, the answer you can see is 316. So 316 studies you require, right, to nullify your result. So if this number is very high, better it is. Higher this number, better it is, right? There is no standard number, I can say, right? There is no standard number, so that I can tell you that if the number is more than this, the studies is having no biasness. But the simple answer is that higher this number, if you have, the biasness of the studies is zero, right? So this test is reported by almost every software and every paper. This is most important test to report the publication biasness. Okay. Now, similar to this test is Glaser and Olkin test, which is also giving you the number of studies. Orwin test, he decided that let's not give it zero, let's make it minus 0.05. Then how many studies are required to reach at this level? Then we are having Fisher. So all these tests are giving you the almost same results, means the concept is same behind all of these tests. But the most important test here is Rothansal test, and this test is known as fail-safe N. Failsafe N, right? So this test will tell you the number of studies you require, or these number of studies are required to nullify your results which you reported in the meta-analysis. So higher this number, better it is. Now let me go to the final test. That test is the most important test, but actually even in this test the concept is quite complicated, and the test is known as trim and fill test. Trim and fill test. Now, what is trim and fill test? So let me explain the trim and fill test. Basically, everybody was looking at a better test after so many tests which are having weak power. So we are looking some robust test, very strong test. And after invention of the computers, so like you can see that this test comes, it is the newest test, new test. And this test is based on the iterative process. Iterative process means manually you cannot do it. The computer will do in the steps. So what trim and fill is doing? This test is finding out the studies which are having a small sample size. Right? In a funnel plot, this is the extension of the funnel plot. In this test, the tests are looking for those studies which are having a small sample size, and one by one they will remove this study from the set of studies and calculate the effect size. For example, this is the funnel plot, and in this funnel plot, I remove this study, then calculate the effect size. I want to see if I remove this, what is the impact come on the effect size. Then I will check if I remove this, what effect comes on the effect size, true effect size. If I remove this, what effect come on the effect size. So this is an iterative process. So one by one, I will remove all the studies which are having a small sample size or which are lying outside the funnel, to check what impact they are having. Right? If I include them, how the effect size change. If I exclude them, how the effect size changes. Right? After that, I will make the reciprocal of these studies represented by the whites. Right? So what are these white dots? So these white dot indicate that these white dot indicate that you need these number of studies. You need these number of studies to retain your effect size. Right? So these white dots are required to retain your effect size. So less is the number of these white dots, better it is, because otherwise we have to remove these white dots, black studies, small studies. Right? Either you remove these studies, or you need these white dots to keep your effect size same. Right? So actually, whenever you calculate the trim and fill test, there are two effect sizes comes. Effect size this, like, and this is the original effect size, and this is the effect size which come if you remove all these studies. If you remove all the reciprocal studies, then the effect size will shift to this or this. Right? So if in other language we can say, if this shift is very small, then there is no publication bias, and if this shift is very high, large, then publication bias is very high. So this test is known as trim and fill test. Now I am showing you all these tests in Jamovi and the Meta Essential, and so that you can understand that what is the meaning of these tests. And let me go to the Meta Essential, and we are going to run all these tests. Okay, now the time to demonstrate the